So we have Braden here from SUNY Brockport, and Braden is going to discuss her study resulting the study of Loon Lake. This project's of interest to me personally because I actually went diving with Dr. Bosch.
Yeah.
And another woman's name, I can't remember the student. We went diving by the aerators and we were looking around and did some surveys and so forth. So I'm very interested to hear what you have to say about it.
Yeah. Well, thank you. Can it is the microphone on? Like, is it? The microphone's on, right? Okay, cool. So yes, I'm Braden. So I did my summer project on Loon Lake. Specifically, we monitored water chemistry, nutrients, and algal abundance for the nearshore aerators and the reference sites to see if aerators would be beneficial to Loon Lake. So we focused on dynamics of major nutrients and algal biomass. So we looked at phosphorus, nitrogen, and chlorophyll. And those are commonly linked to an increase of growth of macrophytes and algal blooms. Throughout the summer study, we also documented changes of dissolved oxygen at the aeration sites, which can be linked to an internal release of phosphorus. Interestingly, it was found that the average dissolved oxygen levels in the water column around the aerators were less than the reference sites, but they were more consistent at saturation at the aeration sites. There are also higher amounts of phosphorus, nitrogen, and chlorophyll at the aeration sites.
So I had some questions. I had some questions about this. One, when did you first put in the aerators? When did you put in?
The aerators were put in approximately 3 years ago.
And they've been in the same location all
yes.
Okay.
So I've been looking at the aerators last summer. I did a different project on them, and this summer was this one. So I've been sampling Loon Lake for 2 years.
And this is an example here of the bubble stream coming.
Yes.
So there's a bunch of little bubbles coming up. It's just air.
Yes, it's a large bubbler, pretty much.
I was trying to figure out this first slide here, or this first graph here, is a dissolved oxygen percentage.
Yes.
Can you explain how did that 100% sounds like as much as it should be?
Yes. With the saturation, it can be like with temperature. I know like I don't know how to explain it.
Is it adjusted for temperature? Is that
basically it is.
Oh,
so it's 100% and 200% of oxygen. Like it is a lot more, but it is also adjusted for temperature. But you can see with the 3 aerators, the oxygen is lower, and it's also a lot more consistent. Whereas at the reference sites, you can see there's just a drastic difference of oxygen, which is natural. But at the aerator sites, it's just very more consistently together.
Does this mean that the same number for each?
So this one, that was a little annoying. It was pretty much like 121, 122. These are averages of.
So close.
Yeah, there's no error bars. It looks like a mistake, but it's not.
Okay, well, interesting. And you were collecting
Yes. So ultimately, we wanted to see if the aerators would help decrease the muck depths. So we sampled the muck depths in September of 22 of last year, which is this blue line here. And you can see it varies so much that we almost can't really tell if the aerators are helping or not. So
this is only aerator areas.
Yes.
Did you try and do a similar area for your reference sites? A similar survey?
No, we did not. This was our first time doing it, so we were just trying to see like, can we get like a reading off of it that we can, like a legible reading that we can understand.
Got it. Interesting. And what would you say is your conclusion with respect to aerating?
In conclusion, we believe that Loon Lake it's too shallow, at least where the aerators are. You said that you dived there, so it's not that deep compared to other places in Loon Lake. So we don't really see there being much of a benefit to have the aerators where they're at right now. now. But this is also like they were just put in not too long ago. It's been 3 years. So we're interested to see like if there's a long-term effect, like if the muck does decrease over time. So we're still like working on collecting data.
So it's a little mixed results.
Yes.
Okay. Well, very good. Thank you.
Thank
Graydon. I appreciate your time. Thanks.
Thank you.
How's it going? Connor, yes.
Carl Hennepin. Did we meet last year? Did you do one last? Did you do a poster last year?
No.
Yeah. Okay. There's another big, tall, good-looking guy. Connor, I'm with doing a Zoom broadcast here, so and I just stuck your microphone in my pocket.
Okay.
And you can either hold that or clip it on, whichever is more convenient for you.
I think that'll be most convenient for me.
Awesome. And I have trick questions for you. No, they're not trick questions. They're
Okay.
leading questions
I'm glad.
to help explain what you tried to do.
Yeah.
So you want to give us a brief summary of what you?
I would love to. So over the summer, I was doing some reading on microplastics because let me make sure I'm in frame. Good afternoon or evening, everyone. My name's Connor Hannig. I'm from SUNY Brockport. Over the summer, I was working with Jacob at SUNY Brockport on his thesis, which was looking at the effects of microplastics on harmful algal blooms. And I was just doing some reading in the literature about that. And one thing I noticed was the vast majority of research uses spherical beads for their microplastics research. But when you look at the environmental data in figure 1, only in the water column, only 2% across 46 different studies, 2% of the microplastics found is in a bead form. And in sediments, only 10% versus 52 and 45% are fibrous. So when you wash polyester clothes, the effluent from that will get into your waterways, and there will be like little tiny pieces of thread that are plastic. And so we don't actually have as much research on the fibers versus the thread versus spheres, because the spheres are so easy to get from the manufacturers. One study I found shows that in amphipods, the fibers will actually stay inside of their bodies for a much longer time. It has worse effects on reproduction.
You said amphipod?
Amphipods.
And what's that?
Oh, that's a great question. Amphipods are tiny little invertebrates that eat algae. They usually are benthic in lakes and streams.
Benthic.
Excuse me. So they like to stay on the bottom of these water bodies. So they go along the bottom of streams and lakes.
Little teeny catfish.
Essentially, yeah. Yep. But crustaceans, so like in the same kind of just as crabs, but very tiny.
Okay, got it.
And so in this study, they showed that the fibrous microplastics had worse effects on these animals than spheres. It was more harmful to them, both on their reproduction and their lifespan.
And yet we're testing spheres because they're available.
Yep, because they're easy to buy. And so
easy to make.
They're easy to make. All the manufacturers that make plastics for researchers, typically it's in a sphere shape. So my question was, what is the difference between these two as far as the ecosystem effects for Daphnia, which are, again, little crustacean filter feeders in lakes. So they'll hang out in the water column, swimming around, just eating algae, doing their thing. And when there's microplastics present, they'll also just filter that and eat it as well. And when they eat that, they will think they're full, or not think, that's maybe the wrong term, but they'll feel physiologically full. However, they don't have nutrients in them. And so their body condition will worsen, reproduction will worsen. And I'm curious if the spheres versus the fibers affect their ability to eat algae at the same rates. We had a little bit of a roadblock acquiring the thread that we were using to manufacture these fibers. So essentially you take a thread that's made to very specific standards, a very specific diameter, in our case, 14 microns, and you freeze it in a line so it's stiff, cut it up into tiny little sections, mount those perpendicularly on a plate, and then use a microtome, which for anyone at home, if you have a mandolin to cut onions, think of it like that. Essentially, you have all these plastics in a bundle with a blade that cuts several times, makes tiny little cuts to very precise standards of, in our case, 40 microns, which is representative of the size of algae that that Daphnia will eat, and it's the same size as some spheres of microspheres we have for plastics, and compare the difference.
Interesting. Well, it makes sense that spheres might be less harmful. There's less surface area per volume, per mass.
Yep. Yeah, so any toxins in the plastic, you'll have more surface area to interact. It's easier to get caught in their digestive tract. It doesn't pass through them as easily, so they spend more time inside the animals typically.
All kinds of reasons to be concerned with it. Wouldn't some monitoring organization like the EPA, wouldn't they specify what kind of material to use to test it? I mean, I'm surprised that it's
To test them?
it's allowed. I mean,
Yeah.
it's not realistic.
So a lot of the requirements around, so your question, just to make sure I understand, so like the EPA, when they are controlling what things can be made, what they care about.
Yeah.
So usually that has to do with the actual chemical composition of the plastic. So different plastics will have different toxicities, and that they care about a lot. But a lot of these microplastics we find are secondary microplastics. And so they're not actually manufactured to be this size. They're the byproduct of larger plastics breaking down. So think you throw a great example from the last little recent time, a disposable medical mask. You just throw it into a stream. That medical mask is made of many, many, many thousands of fibers of polyester. That will break down in the environment. It won't biodegrade, so it will still stay chemically the same, but physically it gets worn down. And so that's what these plastics that we're concerned about are.
Oh, very good. I'm very appreciative of your project. I mean,
Well, thank you.
We need to do realistic testing if we're going to understand how these microplastics
I agree.
affect our environment.
I agree.
Very good. Awesome.
Well, thank you.
So your project goal was to using the fibers. You didn't quite get there.
We didn't yet. We had some roadblocks in acquiring the thread, as well as working with the biology department to access their cryotome. So it's pretty sensitive equipment. No one can just walk in and use it. And so just
Fussy that way.
schedules lining up, we haven't done it yet.
Is it something on your calendar for the next year, or?
Yeah, so actually tomorrow I'm going in with Dr. Rich at SUNY Brockport to make the fibers, and then next semester I'm going to be conducting the actual experiment.
Awesome.
Yeah.
Awesome. Well, good luck.
Well, thank you so much. I appreciate it a ton.
Okay, so what we kind of set out to do was look at the species of cyanobacteria that dominate the harmful algal blooms in the lake, in Conesus Lake. So historically, we've been focusing a lot on microcystis, but we have historical data that shows the most dominant species, genus of cyanobacteria in the lake is Dolichosperma, which is important because they do produce slightly different toxics and have different effects on the lake community as a whole. So what was I trying to say? I don't know. Kristen, do you want to take over?
Oh, okay. Hello.
So you're trying to figure out the balance between these two microsystems?
Yeah, just like the difference in amounts and abundance, and just like to see if there was like a trend, or like you could see in this one how all of a sudden Dolichosperma like really decreased. So we were just kind of looking at different samples during September and October and just seeing like what was up in the lake and what we had.
So you were comparing the percentage of one versus the other, but you weren't looking at how much totally there was. Is that what you're saying?
Yes, so this was actually a graph that I created last year. We had Dr. Bosch had sent me a giant historical data set from just like, so I ended up putting, this was a relative proportion. So I did actually have raw data, but we also had, it was combined with other algae that wasn't green algae. It had a lot of other stuff in it. So this was just proportionally to cyanobacteria versus dolichospermum. What we did differently a bit this year was normally dolichospermum is looked at as a whole genus. We tried to actually break it down by species to see which species was dominating the dolichospermum blooms. So that was a bit different. We have we keyed them out using the Phycotech Cyanobacteria key, and we have some pictures down here of the kind of 5 that we looked at. But yeah, I'll let Kristen.
Okay. So what we did is we gathered our samples from September and October, and then we just kind of looked at what cyanobacteria was in there, what species was more dominant, what was the microcystis count like. For September 2023, we can see that Planktonicum was the most abundant at 50.5% compared to all the species that we looked at, with microcystis only being at a little 4%. And then if we shift over to October, we can see that Cirrusinalis took a big, or not even that big of an increase, but it still remains steady as a high number and did increase. But microcystis really blew up in October, which is because microcystis tends to bloom more in the fall rather than the summer. So it makes sense that from September to October, it had an increase of about 20% or about 16%. And so what we also looked at, besides just what species were in the lake, was the amount of heterocysts that the species had, which heterocysts are little nitrogen fixing cells. They're like right there's one. And microcystis, they don't have heterocysts at all. So we just focused on the dolichospermum and saw what species had the most, and just as a general how many heterocysts on average there were per unit of bacteria. So for September, we looked at the Planktonicum again because it was the most dominant species, and we found out that there was on average 2.2 heterocysts per little unit of bacteria. And then we looked at the dolichospermum as a whole for September, and we saw there was about 1.9 heterocysts per unit of bacteria. And then we jumped back down to October, and there was a big decrease in the amount of heterocysts. So we looked at the heterocyst count for Cirrusinalis, and we found that there was about 0.8 heterocysts per unit of bacteria. And then as a whole for the dolichospermum, we saw that there was about 0.7 heterocysts.
So that would be a bacteria with there has to be some with none.
Yes, there was a lot with none for the October months. But it's just such a massive jump to go from 1.9 on average to 0.7 on average. Yeah. And then we also wanted to talk about the potential human impacts that the cyanobacteria have. So microcystis and dolichospermum both produce the toxin microcystin in anatoxin A group. And then microcystis also produces cylindrospermopsin, which is unique to microcystis. And I know people are always afraid, microcystis, it's so terrible and stuff, but dolichospermum's also pretty bad. They have a lot of the same health problems and a lot of the same irritations that happen. And it's just, gotta look at them pretty bad.
Another important point about kind of the difference between the two is that because microcystis usually blooms in the late fall, there's kind of a lower risk of recreational activity, whereas dolichospermum blooms in the summer. So these are actually, and I should have pointed this out, these are summer averages, whereas these are September and October. Dolichospermum blooming in the summer does produce more of a risk for swimmers and boating and recreational activities like
But
that.
it seems to be a bigger percentage in the fall than in the summer.
Right. Well, we have, so here we've been talking a lot about this jump in 2004. We do have in 2004 microcystis kind of took off as a jump, whereas dolichospermum had less. But since that time in 2004, it's been growing steadily as the dominant species in Conesus Lake. So it's important to look at both of them, and microcystis obviously poses a huge threat, but we also want to put some emphasis on Geneseo as well, since they produce the same toxins.
So I was gonna ask you if this is good news or bad news, but it sounds like it's a little mix of both.
Yeah, I guess it kind of depends the way you look at it. I would say it's not great news, but it's.
It is what it is. What can we make of this downward trend over this 12-year period? 8-year period, I guess.
We have been talking a lot about temperature and how that can kind of change the habitat of the lake, especially over there. Something that's really important to note is, since when we were talking about the heterocyst, microcystis cannot produce its own nitrogen, so it is nitrogen dependent, and Conesus Lake typically is nitrogen what do you call that? Depleted. It doesn't have nitrogen. It's nitrogen limited. So that allows the Geneseo to kind of thrive, since they can create their own, whereas the microcystis needs to get it from an outside source. So if you look, I think it would be interesting to look at, like in the future, the differences in temperature. Is that increasing the nitrogen production of the lake? You know, how is that going to change the environment of the lake? And we do expect to see more HABs in the future, just with the rising temperatures. But it would be really interesting to look at how that's affecting them, like species wise.
Anything else that you want to say?
Anything else? I'm trying to think here.
In fact, you're looking at this, this is very much a concern for the people that are on the lake, self-included, your water ski or your
Right.
swim or
And
whatever.
especially with, I think beach, like I know Long Point Park has had closings because of the HABs and stuff. And I do think it is something that is very scary to people, and can kind of, when you think about the fact that it's the drinking water, it's a bit scary thought, but yeah.
Well, thank you. Thank you both. I appreciate it. Appreciate your time. Yes. Take care.
He kind of collaborated with his
Well, my name's up here too. I'm Carl Henry.
Oh, okay.
So I think together we can get through it. What I thought I saw when I looked at this slide was and first started helping to lay out the way this is put together. There's 4 different data sets that actually sort of agree. I mean, I think that's kind of the bottom line. Maybe there's more to it, but when we think about climate change, especially for us that live on the Conesus Lake, it's to many people, it's something you think about over there, Greenland, Antarctica, the glaciers. It's really happening in front of your eye. Do you want to go through these data sets and say what they are? And you can describe them for us, or jump in if I can.
Fair enough.
Okay.
So my partner and I, who's currently right now doing his own presentation, we focus on looking at the air temperatures and types of seeing if there's some sort of climate change or warming of Livingston County, on top of also seeing if Conesus Lake is getting warmer. So we managed to come across an amazing database that found air temperatures for Livingston County way back, but we wanted to focus on the main period by chance when everything was getting warmer. We tried sticking back between the 1980s to obviously present day, and we actually found between everything that roughly anywhere between 2005 and 2009-10 was when things started to really get warm. As far as with the overall air temperature with Livingston County. And then with this data, we wanted to correlate it to see how exactly the epilimnion temperatures were being affected with their warming.
Let me just ask you, epilimnion.
Yes.
What's that?
So it is the top layer of the lake.
Okay, so near the surface.
Yes, near the surface.
Okay, above the thermocline.
Above the thermocline.
Okay.
Thermocline is when temperature starts to get colder. We're roughly about 1 degree every meter, and that's it's starts out pretty much like warm, and then it slowly goes down to colder, and then it gets sort of a stable temperature as it
You're
goes.
talking about the stuff on the
The
above that.
very surface,
Oh,
yes.
I'm sorry.
No, you're okay. I like the clarification. I appreciate it. So we decided to dive into a little bit of the July and August temperatures, since that was kind of like the peak of the summertime and things started to get super warmer. And we noticed we had an issue towards the beginning trying to find like data from basically the 1980s to about 2005 or so, but either way, it showed a little bit of like a trend, if you will, where it starts to like. I guess the way.
This data was collected by SUNY folks,
Yes, so Dr. Bach, a
previous study.
couple other people worked with Brockport, a couple other like civil scientists, if you will, aided in getting all of this data, with like going and getting temperature profiles of Conesus Lake, to get all the data that we needed as far as the temperature change and Daphnia.
Good.
I just want to say something.
Dude, doing a great job.
What I want to say is if there are any problems or typos in this poster, it's Carl's fault.
I give name for it.
You can't blame me. I just got the data. Don't blame me.
So what I find striking is that if, you know, we think about climate change, and so often we think about it as being somewhere else and somebody else's problem, but we see this is what Avon's intake water temperature, which is 10 or 20 feet below the surface. You've got your surface water testing and measuring that you're doing with your profiling system. We look at air temperature. That's an amazing database, by the way. 1885 to present air temperature in Livingston County.
Patty tells me that Hemlock Lake has been taking temperatures. They've had a weather station since the 1860s as well.
Wow.
Didn't you not know?
Oh, it's good to find out. Good to find out. And this is interesting. My one of our neighbors, Annette Dorflinger, started collecting this data, and my wife started collecting this data somewhere around 2000. Ellen started taking it, and it shows all those databases also kind of a very consistent pattern of warming and or less ice coverage, as the case may be.
Could you talk about the lines here?
I was getting to it, yes. No, fine, you're fine. I don't know if my train of thought even went, to be honest with you.
I think when he landed,
I was talking about like the lines that transition between basically after like 2009 and further.
Right.
We noticed a little bit of a kind of a steady increase, but obviously we would like to see more data. But we saw a little bit of a trend towards like warmer waters happening in Conesus Lake for both July and also August. July was a little more prominent. I do believe we had a lot more data for July compared to August. In August, it's a little harder to be able to see the trends because of so. Either way, with both of these like data pieces together, we did combine them at one point to be able to see overall like the split between the months, and it did have a positive correlation.
Yeah, it looks like if you take the data and you separate it in 2005, and then run trend lines, which are these straight lines, you see a very different slope. And the downward slope means it's getting colder. Upward slope means it's getting warmer, and this is getting warmer at a rate of 0.13 degrees per year. So a tenth and plus of temperature change every year, which is pretty startling.
It is. It seemed like much just because of how small it is. If you think about it in a global aspect, that's a lot.
Think about 10 years represents 1.3 degrees with this slope. So after 10 years, it'll be 1.3, 20 years, 2.6. That's gonna make a big difference over the course of a lifetime or two.
My partner and I tried to look to see if we had any idea of how to like forecast it. but with not having the data and obviously Mother Nature having her own plans as far as how everything goes, it was a little hard to be able to see what it looked like 10 or 20 or 30 years from now. But we just wanted to like throw an idea out there that it's going to increase ever so steadily over the next couple of years without knowing what exactly is going to happen between now and then.
Right. Because there may be some positive or negative feedback effects that we're not
Yes.
sure about.
Can you folks hear me?
Very good.
Can you hear what I'm saying?
Question?
Can you hear me?
I can hear you, yes.
Yeah, do you have any of the data from Ken Stewart from the University of Buffalo? Because we took temperature readings in the late 70s and 80s for him in the summer.
Oh, really? From you? I'll have Dr. Bosch take a look at that. I'm not aware of it now. And I've been sort of monitoring the lake temperature in Conesus for a number of years. You know, but
He
I'm
did,
not sure.
he was sampling Hemlock, Conesus, maybe Canadice and Silver Lake. He was monitoring 4 of the lakes, but we did Conesus for him in the summer every week, and we did the temperature at each meter down to the bottom.
Let's pass it off.
We'll pass it off.
Yep.
So we're gonna learn about the differences between Hemlock and Conesus Lake. And the other thing we're gonna learn is how to pronounce this word. Is it Herbivory or Herbivory? Or-
Herbivory. Herbivory.
Okay, I was putting the accent on the wrong syllable. Okay, very good.
Yeah.
Very good. Can you tell us a little bit about what you did?
So we wanted to know why there was such a difference between Hemlock Lake and Conesus Lake and the water clarity. Hemlock Lake is known to have very clear water with low amounts of algae, while Conesus has doesn't have as clear of water and has pretty high amounts of algae within its water. So these differences could be due to Hemlock having lower nutrient input from the surrounding area and Conesus having higher. But we also wanted to look at the Cladastra, which are little microorganisms that are in the water, which eat the algae. And the more algae they eat, the clearer the water can get. So we want to see if there was a difference between Hemlock and Conesus, and if that was why there was such a difference between the water quality there.
Is it like on? I don't.
Just right on the side. The microphone is actually right.
Oh, okay.
I wasn't pressing anything, so.
Hi, I'm Lacey. I don't know if any of you guys live near the Conesus or Hemlock areas, but in order to kind of understand where we're coming from with this project, you have to understand the differences in the agricultural and residential percentages around these lakes and within these watersheds. Conesus Lake, I'm sure most of you probably know, has a way higher percentage of agricultural and a little bit more residential than Hemlock. Conesus only supplies the Avon and Geneseo areas, whereas Hemlock is supplying all of Rochester. So it is very regulated for a good reason. So what we did, we took 2 samples, one from Conesus, one from Hemlock, from last year in August and September, or no, just August, I'm sorry. This year we went out in September for both lakes. We scooped up a bunch of these little guys. We put them on a little slide right here, and then we measured them. The measurement kind of corresponds to their size, first of all, but it also corresponds to how much they're taking in, or how much of the microalgae they'll be taking in, so we can compare really the intake of the lake.
And since the sizes of the Cladastra between Hemlock and Conesus Lake were pretty similar. That also showed through how much water they were able to filter, and therefore how much algae they could eat. For Conesus and Hemlock Lake, they were very similar in the amount of water that they could filter through. And that was true for August of last year and September of this year. It's not, so that leads us to believe that the nutrient input is more important in determining the water quality and the how clear the water is in the lake.
Yeah, so we looked at the specifically trophic state index averages because we were trying to do herbivory, and then we were like, okay, maybe it's nutrients. So we calculated individual characteristics of the tree, of the lake, and from different samples that we had tested. Trophic state index also refers to just the overall state of the lake and just the nutrients involved in it. So we have this raw data here, and basically after calculating all of those averages, we saw that the Secchi depth and phosphorus were roughly 15 to 20% higher in Conesus Lake compared to Hemlock. So that really just shows us that the nutrients do play more of an impactful level of determining the state of the lake compared to the herbivory, which definitely tells us why the clarity in Conesus is the way it is compared to Hemlock Lake.
The only slide that was sideways. You had the only slide that was sideways.
Oh, yeah.
Okay. I had some trick questions here for you. First thing, somebody, whoever's speaking, if they could just hold right in their mouth so it can be heard.
Oh, do you want to go first? Speaker? I think it's a microphone.
Let me just ask you. You've got this title up here. I looked at this for a long time because they sent me a copy of your slide. Community dynamics of photosynthetic and heterotrophic bacteria during July blooms in Conesus Lake. I understand the last three words, but the rest of them I'm not so sure about. Can you...
So community dynamics just refers to like how different species like interact with each other. So like their population sizes and how they affect one another.
Okay, got it.
Photosynthetic bacteria are bacteria, just like very small bacteria cells in the water that use sunlight to produce energy. And then heterotrophic bacteria are bacteria that can't use sunlight to produce their own energy, so they have to feed on other bacteria.
Okay, so can I say that you're kind of examining the pattern of the food web?
Yeah.
In July blooms in Conesus Lake.
Yes, exactly.
I understood that. Thank you.
Yes.
Okay, we're done.
Okay.
I'm sorry.
Okay. Okay, so we've been observing blooms people who live around Conesus Lake have been observing blooms on Conesus Lake since around 2011. It's a phenomenon that tends to happen every July, usually mid-July, and lasts for a couple of weeks. And the photosynthetic and heterotrophic bacteria bloom rapidly. They're very small. They're usually less than 1 micrometer, so they're microscopic. But they can affect the clarity of the water because they exist in such dense numbers. So we've seen upwards of 300,000 cells per milliliter of water during a bloom. So like, as you can see from this picture, it can turn the water like a greenish color. And this graph kind of quantifies the clarity of the water from the bloom this summer. So the red line is referring to the Secchi depth during the bloom, which basically shows that you can't see as deeply into the water when the bloom is really dense. And the blue line refers to another measure of clarity, which is turbidity. So it's basically just means that the water is murkier during the middle of the bloom. And then we had two main questions that we wanted to answer. So we wanted to see how the photosynthetic and the heterotrophic bacteria types interact with one another. So how they affect one another, if they would have a similar population trend. And then we also wanted to be able to perfect a method of counting the heterotrophic bacteria. So we've been able to send the photosynthetic bacteria to a lab to be counted, but we have never gotten accurate counts of the heterotrophic bacteria for Conesus Lake. So that's something we wanted to do. And how we went about doing this was with samples that we had from the blooms this past July. We filtered those samples, and then we did a cyber gold fluorescent stain on them, on the filters, which basically stains anything that has DNA in it, so all the types of bacteria. And then we were able to analyze the filters under a epifluorescence microscope and take images from them under different filter sets. And so under some filter sets, you can see all of the different bacteria, and then other ones you see just the photosynthetic bacteria. And we were able to take pictures of those and then use imaging software to count how many cells there were in each picture.
I wanted to, before you go too far, I wanted to just do one thing real quick. So just to clarify first, the picture on the left is the one, it looks like the stars at night, but this looks like a very clear night. You see a lot of the stars, and this is a fluorescent stain for all of them.
They were all stained, but this filter set.
So this filter set under the microscope shows all of the bacteria, whereas the other filter set only shows us the photosynthetic bacteria. So you can see that there's a great number less of photosynthetic bacteria than heterotrophic.
Thank you.
Yes.
All right, so here are the results of our new method of counting using the filters. So on this graph, it is the heterotrophic and photosynthetic bacteria by millions of cells. On the left axis, this is millions of cells for the heterotrophic bacteria. You can see them in the blue, and they peak at about 1.8 million cells per milliliter at 720. And then the green here is the photosynthetic bacteria, and they peak at about 220,000 cells per milliliter at 720. And as we were hoping to observe, they are very close in when they increase together, and they peak at the same time. And then when they decrease at about the same time. This is likely because the heterotrophic bacteria feed on the photosynthetic bacteria when they die off. So we were expecting to see them kind of like have an interlinked relationship to each other.
I have a question with this one graph.
Yeah, absolutely.
You say they peak at the same time, but you really don't know that. If I interpret the graph correctly, this could peak over here, and this one could peak over here. And because the low frequency of your sampling.
Yeah.
So that is one thing that like
if you're measuring peak.
Right.
So in the future, like we would like to be able to have samples from every single day so that we can, because things this small and with such large populations can change on such a small amount of time. But yeah, so that is one flaw with it, is that you have 3 or 4 days between sampling. So you don't really know how the numbers are in between.
No problem. That's a very fair question. And I talked with Dr. Bosch, and he was saying how it can change even within hours. The populations can change drastically. So this just gives us a general trend. And we weren't able to get, I guess he wasn't able to get on the lake that many days. So this is just the data we had. But we are still able to observe kind of that general trend of they go up at the same-ish time, they go down at about the same time. Yeah. And then so the previous method that we were using at SUNY Geneseo was using a hemocytometer to get cell counts, which isn't exactly super accurate for bacteria because it's meant for blood cells. And then, so this in the blue here, this is the hemocytometer counts by date in millions of cells on the y-axis. And then here is our new filtered count. And you can see that the difference is pretty substantial. And as we already knew, the hemocytometer is overestimating by quite a bit. So this allows us to get a lot more accurate counts and have people further take this research to use those counts, analyze the data more.
So why we're excited about this, obviously we were able to successfully count the heterotrophic bacteria for the first time. So that's super exciting. We have those counts for the lake now and we know it can be replicated. We spent a lot of time formulating these methods, a lot of trial and error, and ended up actually going with a different stain than we initially thought we were going to use. So this is exciting for Geneseo. Our research can be done a lot quicker. We don't have to wait to send everything off to the lab to get accurate counts. We believe our counts are pretty accurate based on comparing them to the lab values. So this will be really helpful to directed studies in the coming semester that'll be building on this research and using these methods. And we're pretty happy with where we ended up. This is the expected trend we wanted, but we would really like to, we noticed the same thing you did, that we don't really know where the peak is, and we kind of believe that it might be actually in between them, but we're unable to establish that at this time. So
Very good.
yeah.
Good. Okay. Any other discussion points that you wanted to say? So it says there are plans to continue research using these methods. So other folks who are in the university are going to be
Yeah,
doing
so next semester, there's some directed research, so research that's going on outside of lectures with specific students who've already taken this class, who will be using these exact methods to count bacteria, but they're also trying to identify phages, viral phages in the water that might be contributing to the rise and fall of these blooms. Yeah,
Did they name this method after you? Do you get?
I wish.
I don't think
that's
We actually struggled with what to call our name on this graph, so no.
Yeah, I tried. Well, thank you very much.
Yes.
Yeah, thank you for your time.
Great stuff. All right.
So we're just about to finish up our SUNY Geneseo and SUNY Brockport presentations. What I will do is ask the SUNY Geneseo students to come forward and all in a group, join your classmates here so that we can record your official thank you and handing out of certificates for all the work that you guys have done. And Professor Bosch, if you step forward with the students, that would be fantastic. This is our annual presentation. SUNY Geneseo and SUNY Brockport do join us every year. And I have to say that our student presentations are on our favorites list. They're always well attended. Thank you for joining us in Zoom, and thank you for joining us in person. And in 2024, we will have student presentations again by SUNY Geneseo, SUNY Brockport, and our Livonia Central School. All right, so if I could just take a moment, record in history these thank you and certificates for Dr. Bosch,
Thank you.
for Caitlin, for Emma, and Kristen, Lacey, Micah, Kelly, Kayla, Ryan, Daniel, and Noah could not be here today, but he has one as well. If we could have a nice round of applause for our wonderful researchers. Thank you. And now if we could shift over to our SUNY Brockport cohort. And thank you for those folks online sticking with us. Dr. Chislock. And Braden, oh, I'm sorry. That got me the last time when you were presenting. And Connor, no, that's good. It's good. Keep me on my toes. And a nice round of applause for SUNY Brockport as well. And that concludes our last Watershed Education Center program in 2024. This makes, we have reached 3,000 people as this evening. Well done.